manufacturing, technology, hot topics, and a little bit of tomfoolery. This is the MTD Podcast.
Hello and welcome to today's MTD Podcast, episode 19. Don't say tomfoolery's not here, Gio. Today.
I'm not going to. I'm not even going to attempt to say tomfoolery's not here.
Both Gio and myself here today on the hot desk, and we're going to be talking primarily about turning centres and some of the pitfalls and some of the things to look out for when you're purchasing them. If you'd have listened to our last podcast, we did this on vertical machining centres, and that seemed to gain a lot of traction. So today we're going to do it on turning centres. But firstly, Gio, I want to talk to you about this rather nice prized possession we have here on the table. And for those that didn't see the football match, we won it.
I know it was a unbelievable evening. I mean, it was fantastic.
What a victory! And if you weren't aware, MTD CNC played FANUC UK at 7-a-side football on May the 8th, and you can watch the game on our YouTube channel, and it is definitely worth a watch because there's lots of good stuff in there, isn't there? Even some football.
There was a bit of football in between, but yeah, it was a brilliant night. I was just gutted that I couldn't play myself, but hopefully...
Who was best player, Gio? Because you were on the sidelines. I've got my opinions.
I think it was a close call between Joe the Juggernaut and Deadly Deadman. I think them two were absolutely outstanding. Joe's goals, I mean, the finish was... I mean, it might have been...
Did you see do you know who the... That was a loaded question, by the way, because I was hoping that you were going to say me. Did you see the assist for Joe's goal, though?
It was good, and I think you were very influential on the pitch.
Every goal, I was in the assist, but I was hoping we were going to put something at the end of the broadcast where we'd have assists, corners, throws, possession, and all the rest of it. Because I know I'd have come top on the assists, although I didn't get a goal.
Right, I thought you played well. I thought you were dead influential. I thought the whole team played well. I thought it was a good game.
Yeah, it was really good, really good. So yeah, it's on our YouTube channel if you want to look. Okay, so let's kick this one off then, Gio. Turn-in centres, the pitfalls. I've sold quite a lot of turn-in centres in my time. In fact, there were, to me, the turn-in centre and the VMC were the most... or the largest selling range of types of machines. But of course, to start with, you need to make sure when you're buying a turning centre that something simple, the size, isn't it? That's important. You need to make sure you've got the right size of machine, not just for what you want, but what you think you might need. I mean, yeah,
it sounds, common sense, doesn't it? The size, but how many people, buy a machine and then they haven't future-proofed it, and then the next minute they get an inquiry for a job that they can't do on their lathe. So absolutely, I think one of your main considerations need to be the size of components that you're going to manufacture, but not only the size, the material of the components. Are they going to be hard? And also the tolerances in which you're going to be turning the components down to. What kind of tolerances are you going to be working to? Are you doing work for the aerospace industry? Are you doing work for, the agricultural industry? There's a big difference,
But I think the turning centre size thing, and I make this mistake when reviewing machines. I often say, this is an 8-inch chuck machine. This is it's got this amount of swing and so forth. But it's actually looking at going into it in a little bit more depth, like looking at the collision areas. So you might have a 6-inch chuck on a machine, but your swing might be a little bit less because your turret might be bigger. Some turrets are bigger than others. You get 12 stations, 16 stations. You get different styles of turrets, so VDIs, BMT turrets. So those turrets vary in size. The length, the tailstock might be bigger, so it might might encroach on other areas of the machine. So it's about that working space as opposed to maybe some of the characteristics we mentioned.
Absolutely, I think the fresh air space within inside the machine, and when you've got the bare spindle nose, you've got a lot of fresh air space, and that can be misleading in a way sometimes. I think that dependent on what work you're doing, again, will govern you into what work holding you put onto your machine tool. And then the work holding options are very important as well, because you get some very compact chucks with clearance so you can get closer with your tools on your turret, especially if you're milling. That is, you don't want to be sticking out your end mills a long distance when you're using them with live tooling. So it's a really, really good point, Paul. And also the through bore of your machine is very important as well, and the through bore of your chuck. If you're doing shaft work, again, you want to bury that shaft as deeply as you can into the main spindle. So you've got the part that you're turning as close to the chuck as possible, again, for rigidity, etc.
Yeah, and even on small turning centres these days, maybe a 6 or 8 inch chuck style machine, you can get up to 76 mil bar capacity and beyond, sometimes 90. Which again, if like you say, if you want to bury into the spindle, you can do that. Nothing worse than having a 2-inch bar machine and having bigger bar that you need to get down the spindle.
Yeah, it's game. You can't do it. You can't do it.
On the turret one, the difference between having the 12 and 16. Often people say, "Great, I've got more tools," and we'll do it. We got, this has got a 16 station turret, and you've got more tools. But with that, it means the turret is going to be bigger, so you are going to reduce your working area. So I suppose that would then. You would then consider whether you need the more tools, but you can afford to go for a smaller working area because the 16 is an option on some machines.
Yeah, I think the pitfalls, when we say pitfalls, and a lot of people will buy a machine and then try to put the work on the machine. And then they have got the restrictions of the capacity of the machine. Other people will look at it from a different perspective and say, right, these are the kind of parts that we're going to do, but this is the biggest part that we've ever done, but let's future-proof ourselves and put a little bit more size onto that, and let's base our machine tool on that. So we're future-proofing ourselves, give ourselves every possible chance of being able to win as much work as we possibly can.
Good point, but if you go bigger, you will compromise in another area. You'll compromise maybe on the speed of the machine and potentially the agility of the machine.
That's a really good point, yeah.
So is it down then to cycle time? You might go for a 12-inch chuck style machine instead of a 10. And listen to me, I'm talking about chuck sizes again, when really, we know that those aren't necessarily the most important factors.
That's a really good point.
But if you go for a bigger machine, it's going to be slower. Spindle RPM is going to be down to 2,500 or 3,000 RPM, as opposed to a 6-inch chuck style machine where it will be 5,000 or 6,000 RPM. So you're turning. There is always that balance and that juggling.
But that's the point really in regard to picking a machine totally. Around your components rather than picking a machine and then trying to win the work. And that's and I think that's the dilemma that a lot of engineers have got really. Not everybody are making their own components and they know what they're going to make. If you've got that luxury, I think that you could really you'd get the best solution, wouldn't you, Paul? Because the work that you've got, then you can really get them cycle times down and keep improving that process, get exactly the right machine that you need, absolutely down to a T to make them components. But when you're not really sure from week to week what
you're
work...
You're a subcontractor, which is the majority of people that will be listening to this. Even the axis movement, like for example, the Y-axis. I mean, there is a machine, and I'm trying to rack my brains to think what it was that I saw recently, where I looked at it and the footprint was small, but I looked inside the machine when the doors were open, and I was so surprised at how much space there seemed and how much capacity there was, and it had a much bigger Y-axis as well. It actually had a plus or minus 70 millimeter Y-axis. So the working envelope was much bigger, and the fact that it had that 140 mil stroke on the Y-axis meant that you could... you
go past center.
You could go past center, and you could do a lot more on the machine than most other machines of that size. So that's about the size as well. The Y-axis, the size of the turret, the swing, all of those things. Then of course the footprint. Where's it going to fit on the shop floor? How often do we see machines where you'll see them? They're massive, and then you'll look in the doors and you go, actually, it doesn't look like there's a lot of turning capability or not. Big envelope in there, and then the supplier will say, yeah, but it's a big heavy duty robust machine, and you're like, okay, so which of these do I want? Do I want something that's 20 tons, or do I want something that's 8 tons but smaller? So
yeah, absolutely. I think that again it comes down to maybe the materials that you're cutting, if it's just soft materials, plastics, aluminiums, or if you're going into your Inconels and you specialized materials, then maybe you need that extra rigidity, that extra torque to be able to cut through that material and still have the longevity of the machine tool. But a good point about the footprint, Paul, if you're just doing billet work, and low volumes, you probably just have your lathe without any automation. But more likely than not, you do see lathes with a bar feed nowadays, don't you? When you go into most shops, you'll see a bar feed at the end, and probably the bar feed takes up more floor space than the machine in some circumstances.
Yeah, well, absolutely. On that build of the machine, though, let's look at then how they're made, because I've got something interesting which I've found out probably about a year or so ago, and it seems so simple, but the castings and the bases of the machines, some turning centres have 40 degree bases where the slant bed, they're 40 degrees. Some have 60. If I'll ask you a question, I'd be interested to know your answer. Do you know why they offer different, and what some of the reasons for offering the different styles are?
Is it based on the turret to give clearance around the turret, and swarf evacuation?
Yeah, possibly there could be factors, but one of the main things is that the 40 degree bed, which is less steep, there's more weight at the bottom of so that the sort of centre of gravity of the machine, it's heavier closer to the ground, so it's more, so they'd class it as a stiffer construction. Whereas if you've got 60 degrees, there's more weight at the top of the casting, so therefore it's further away from the ground. So that someone would say it's not so stable. So people would say, if you go for what's the angle of your casting? It's 40 degrees. That means it's more weight at the base, which means it's more solid, which means it's more stable.
Never heard that. That's the first time I've heard that.
So that is just something that I found out looking at a turning centre, and it was actually on a big 15-inch chuck, heavy duty gearbox lathe. And the fact was, this is a 40 degree casting. Oh, well, because of course the weight is at the base of the machine, which means it's more stable. And that also had a gearbox spindle. Now we all know what a gearbox is, but to me, I still look at it as quite old fashioned.
It does sound old fashioned. I mean, when you've got the Colchesters, the manual Colchester, you had to change gears to increase or decrease your speed, but it's more for the torque, isn't it, Paul?
Yeah, it's all low end torque, and it all does it automatically in cycle. So really, although you say it's a gearbox, there is a gearbox in there in the hardware, but all the clever stuff's done in the software. So you haven't got a guy standing there going, I'm going to run in gear 1, I'm going to run in gear 2. It will select based. So I then think, well, why wouldn't you naturally go for a gearbox on a machine? Because everybody wants to get high power or high torque at low speeds, and they also want to get high speeds as well. So why don't you have it?
I think it's because of cost. I think if you've got a gearbox machine, I think it'd be more expensive. And I think that if you were doing certain work that didn't require that torque and that grumph, if you were just, again, doing aluminium work, you might not necessarily need to have a gearbox to cut through the aluminium. So you'd kind of be over-speccing the machine for the application.
So then would you go for belts? Would you have a belt? Because there's still quite a lot of turning
there's still belts out there.
Belts.
I mean, I'm not a big fan. Hopefully I'm not upsetting anyone, but I'm not a big fan because I have used machines only sometimes. You've got a new one, by the way. But
MTD
that's
belt.
another story. But yeah, I mean, with a belt, if you're taking a really deep cut, you can actually slow the spindle down. You can actually physically, but again, if it's for the right application, it works. You're buying the machine that is right for your application at the right price. Why would you go and buy something that's totally overspec'd for your application? It doesn't make any sense. So I think that the fact that there are so many lathes out there indicates that they're all, and I keep saying it every single time, but it's application specific, isn't it, Paul?
But they are, the belt driven machines are going to be cheaper.
Absolutely.
They're easier to repair.
Yeah.
Taking out a gearbox spindle and repairing it's going to be more costly than a belt. A belt snaps, change the belt, job done. I suppose it's a bit like the belt on the old car. The fan belt broke, and you put a new one in, and you're away. So there's the cost implication. But I agree, you won't get the same, I don't believe, performance long term out of a belt spindle, but you can replace them easy. So maybe why would you need them? I want to now mention about tailstocks. I know machines can come with sub spindles, but predominantly machines are purchased with a tailstock.
If it's single spindle.
If it's single spindle, yeah. But there are some twin spindle machines that have a displaceable tailstock below the second spindle.
Oh, so if they're doing long work, if they're doing,
they can still actually on the second spindle be turning. With the second turret, for example, but there's a few manufacturers that do them. The tailstock will come underneath the second spindle and it will support the first part, so for longer shaft work. But a tailstock on a machine, simple as it sounds, they either generally tend to come as programmable tailstocks, and they're drag and drops, or they can be driven by a ball screw. Some would argue the drag and drop is the cheaper method, but by having it on a ball screw means it is an independent axis, essentially. But then some machines, and I got caught out with this selling machines, that you sell them and they're actually programmable quills. They're not programmable tailstock. So you need to move. The tailstock into position, and you can sell a machine to someone. Is it a programmable tailstock? It's a programmable tailstock. Yeah. But it's not. It's a programmable quill. And how much of a pain can that be for someone to have to keep intervening to move the tailstock along? So it's one thing to definitely be careful of. Have you got any experiences of people that have bought turning centres that are wrong?
Yes, I have actually, Paul, and it comes from, I don't want to say that they actually were wrong. However, when I worked at Clemonta many years ago, they bought two Puma lathes.
I sold those.
You sold them, and they had all the live tooling on, twin spindle, and it wasn't any fault of you, the sales guy, but it was at the time. I by the way, I worked on the milling section, so I didn't have anything to do with it. But at the time, the people on the turning section didn't know how to. They weren't confident with that technology. They'd not used live tooling and milling on a lathe, and they didn't utilise the machines and use them to their full capabilities. So effectively, they could have done the work that was being done on them on a lesser machine. So it wasn't that they were wrong as such, but they weren't used to their full capabilities.
And this isn't staged, you know.
This is true story.
Yeah. I'm not just saying this because I did sell them and I sold them to the managing director of the company. Yeah. I think that was half the problem because the MD got excited by the technology, yet he didn't involve any of the senior shop floor staff in that purchase. Yeah. He simply said, I want a machine that's got all the capability for the best possible price, without maybe considering getting other people in to look at what was actually best for them.
Yeah, and I can remember the part. Well, I can't remember them 100%.
Like some kind of aerospace adapter.
It was only a tiny little part, and I can recall thinking to myself, well, one, the machine is too big for the part.
It's what we had in stock.
You know, it was huge for this tiny little part.
I can remember it now. Yeah,
and two, you know, you've got all these axes on this new fantastic lathe that are not being used, so it just didn't make any sense to me. And it was a very high volume work as well, wasn't it? And so that part stayed on there 110% of the time, and that machine really was quite. It was a machine. For me, a flexible machine to do lots of different work and really get your teeth into. But that is a funny story, Paul. And that's one story that it is a true story. We've got talking and it's like, blimey, I can't believe that.
Swarf conveyor, swarf extraction, right? Two different types in my head, slat, chain. Why do you use one and the other? Because nothing worse than getting a machine in, turning centre in. Well, firstly, make sure you get a swarf conveyor, because often you can buy a machine and I don't need a swarf conveyor. Well, you do, because you don't want to be digging in and out of swarf. I mean, that is a nightmare. And I've sold machines without swarf conveyors because people have cut back on cost. I don't want to spend $2,000 on a swarf conveyor. Well, really, you're going to lose that over the course of a month, because you're going to be in the machine clearing it out. But I've also been involved in situations where I've sold machines with the wrong type of swarf conveyor, because both myself and the company didn't necessarily know what was right. Different materials, whether you're chips or stringy swarf, really needs a different type of swarf conveyor, doesn't it?
Absolutely, Paul. And I think that, you know, swarf conveyors, coolant, through spindle coolant, these are kind of considerations that sometimes get overlooked massively. And I think that when you're selling a product to maybe the MD of the company that maybe is more involved with finance than being on the shop floor, it's something that more likely than not does get overlooked, and it's only when the machine lands that they think, oh no, we've this is big trouble here. But I think that things have really advanced over the years. I can remember when I was on the shop floor, we didn't have all these swarf management systems. You know, these now have evolved in regards to, they're not just clearing the swarf out of the machine, but they're controlling the coolant levels, the pH levels within the coolant. You know, they if you want through coolant at a special bar pressure, you've got that now, because again, you know, to be able to cut so fast, you need that coolant to come out very quickly and keep the tips
cool.
Thing
is, with that through spindle, you have to specify that on purchase as well. That's I believe, and correct, you know, please comment if I'm wrong, but I think to retrofit through tool coolant on a, let's say on the milling of a turning centre is you know, or is unlikely to happen.
We used to sell,
especially if you want high pressure 70 bar or 80
yeah,
bar.
I think it can be retrofitted. I don't know. You know, there was something, a product we used to sell called Cool Jet. So it can be retrofitted, but I think it's problematic. I think it's the same with it's better getting it at the very, very beginning, in my opinion. You know, like if you spec up the machine with a full swarf management system, and I think that they come into their own as well, is when you're producing a lot of swarf, Paul, you need to clear that swarf quickly. You can't have it or create a scenario where the swarf is filling up quicker than you're removing it.
But we've all seen it. We've all seen it. I've all seen it. He keeps banging his hands on the table as well.
Oh, sorry.
I mean, we've all seen it. The swarf building up into the machine, but that's also down to potentially the way you're machining it. Because with things like high pressure coolant and sort of clever programming techniques, you should be able to get better chipping of a part. So with through spindle coolant, the power of the high pressure coolant will actually hopefully eliminate some of those problems. So it's definitely an option.
And that's another really good point there that you've just made there, Paul. If you're creating smaller chips, then obviously your swarf is going to be more condensed and take up less area space within the swarf tray, etc. So you've got more kind of area of swarf to fall into.
Yeah. I just want to touch on the turrets again. VDI turret and BMT. Do you know the difference between them?
They're just two different configurations where that actually drive the live tooling.
Do you know which is best for what?
I don't know.
The VDI is faster to change. VDI tooling, it always used to be sold based on the fact that it's very quick to change, and the BMT is a little bit more stable.
Right,
it's a little bit heavier duty. You get more power out of a BMT turret. And interestingly, I find now less VDI machines out there than BMT turrets. I don't know whether it's just where we go, but I tend to find that the heavier duty, stable, more powerful turret tends to be the BMT. You can get VDI 30 for smaller machines, or VDI 50, which is a bigger sort of shank, which is again supposed to be more stable, but the BMT is more stable. But the VDI quicker to change.
Didn't know that, and that's a really good point. And I think that leading on from there is the live tooling and all the different configurations of live tooling that you can get now for the lathes. I mean, how I kind of look at these lathes now with live tooling is if you can imagine a VMC with a fourth axis unit on there, and you've got your billet sticking out of your fourth axis unit, and you can mill all around that. Basically, you've got your C-axis on your lathe now, and you're actually replicating what you're doing on a VMC, but with turning capability. Yeah. So, I mean, when you think of it like that, that should also change your thought process in regards to the kind of components that you can manufacture.
But on that turret, and to be able to do that, often with driven tools, power can be an issue. There are sometimes, they're not man enough. A driven tool turret isn't a milling machine. A driven tool turret is a second opping solution. But I have seen driven tool turrets with up to 15 kilowatts of power. So that's a little bit of a contradiction from me there, because they are getting more powerful to be able to do those more required heavy duty milling. But the turrets themselves, I spoke about 12 and 16. VDI and the differences between BMT, but the tools on them, like you say, you can get driven tools that point out both ways, so you can bank up.
Work main and second spindle.
Main and second spindle. Yeah. And the turrets now, they have their double point indexing, so they have 12 stations, but you can actually index a half index, so you've got 24. I did come across a situation the other day where someone they didn't want a turret with 24 point indexing because they wanted a turret with 16 stations on. So I get this, so basically it was a case of I either buy a machine with a 16 station turret, or I buy a machine with a 12 station turret with 2 point indexing, which gives me 24. And I want to get as many tools as I can. So which one do you go for? And he said, I went for the 16. I was like, well, why did you go? Because there was less opportunity for collisions with the way the turret indexed. Because the tools were too close together on the half point indexing.
So you've not got clearances between. You've got more clearances. If you've got 16 tools, there's more clearances in between each one.
Correct. And exactly that. And also the cost of the double point tool holders as opposed to single one. You only has to buy one set of tool holders as opposed to double point.
Good point.
So, that's little things. Just on the... looking at twin spindle machines, you can have twin spindle, you can have two turrets, and both the turrets can work on balance turn on the front spindle, or you can have turrets that work one on the back and one on the front. And you can have turrets where they work on front or back, can't you? Which again is the more sophisticated turning centre.
Doubling up. You're doubling up, aren't you? If you had a twin spindle lathe where you're just working one side, your second spindle is staying idle until you start turning the second side. Although you are doing a part complete in one cycle, but with this now you're kind of constantly cutting on both spindles all the time. So effectively, you're being more. It's more of a production machine, isn't it? So you're saving seconds. And
another interesting one. I was in a company the other day. They got a big turning centre, big twin spindle turning centre, and they were machining 303 stainless. The diameter of the part was about 65 mil. But the remnant was falling from the second or the first chuck or the second chuck, and it was hitting the bottom of the conveyor, which over a period of time, imagine that, it was damaging the conveyor. So he was having to buy new conveyors. Now it's a stupid thing. It's a stupid thing, but it's a reality. So how about removing remnant ejectors for parts and things like that? These are important too.
Oh, absolutely. Well, when you've got a short bar feeder, a lot of them don't have remnant retract, so the remnant at the end of the bar gets pushed out of the front, and like you say, you go and buy a big expensive
is there such
machine.
A thing as remnant retract?
When you've got a long bar feeder, it will actually retract the remnant and drop it out the back. So that that's one of many advantages of having a long bar feeder, especially when you're doing like 65 mil bar. It's a big chunk.
You should have seen the bottom of the machine. I mean, honestly, it was like
and the noise which it must make when you're just dropping that out.
And it was a continual problem. It was a problem that was causing them to have to replace swarf conveyors and parts at the bottom of the machine.
That's a perfect example of kind of considerations to make when buying a lathe, really, because he probably bought a bar feed for 10 grand, but if he'd have bought one for 30 grand, not only is he got remnant retract, he's not having to chop his bar up into 1.5 metre lengths. He can be running 3 metre bar and saving money that way as well, and running for longer. Lights out, good point.
Accessibility of the machine and the control systems. Well, we all know the different options in control. For example, the FANUC, Siemens, both popular systems. Heidenhain do ones for turning. Also, companies have their own bespoke controls. But something I picked up on as well is when these turning sensors have the controls and they're just embedded into the machine, makes it more difficult for an operator. Where I've seen 2 or 3 where you can pull the control out. Again, stupid, simple little thing, but when you're setting a job, if you can pull that control out, you can see all your control screens, where your buttons are, as opposed to having to keep coming out, looking around,
I totally agree with that, Paul, and I think that this is something that maybe designers have taken for granted in regards to they just assume that you write the program and you press go and it's going to be right, and a lot of people don't like that, and I think that is starting to cause a return of the wash windows in a lot of machines. They're starting to return, and I think simply down to that, we're making a lot of complex components, and it's nice to be able to see what you are making. And I was going to get onto another point, actually, Paul. Sorry, I was digressing there, but also from that, we went to Colchester recently, and we've seen the combination lathes. Now, another consideration is if you were doing very, very low volume work, and I mean, we'll use Downhurst Engineering as an example here. Rob Payne, he's got his full CNC lathes and he's got his combination lathes as well, and he couldn't praise the combination lathes enough, because sometimes he does a rework or a low volume part that if he had to go and put that onto a CNC lathe, it'd be an absolute nightmare for him, because there's a lot of feely, touchy, being able to repair a part or just be able to return one diameter. To put it onto a CNC lathe, you've got to write all the program up, you've got to set it up, you've got to stop the production. But having that combination lathe there, you can just whack it on and done it within minutes.
Yeah, applications, to coin your phrase. I might have said final point already, but this definitely is it. I want to come back to the build quickly. We haven't mentioned linear rails, box guideways, linear motors, thermal growth. These are all aspects as well, aren't they, on a machine? Box guideways generally tend to be slower. However, I did see someone again recently who had a box guideway machine. I'm trying to recall the manufacturer. Oh, it's the Kitamura. Kitamura machine have box guideway machines, but they're the fastest rapids on a box guideway machine, up to 60 or 70 meters a minute. No other box guideway machine does that. Wow. So there you've got the benefit of the box guideway construction, fully hand scraped box guideway construction. I know Kitamura is a machining centre, but the box guideway tend to be slower. They tend to be a bit more heavy duty, last longer, and the linear rails seem to be faster. So again, I bet that just depends on what you want to do, doesn't it?
Absolutely. I think, again, that is a big consideration, isn't it? Massive consideration, and it would reflect, I would imagine, quite heavily on the price.
Yeah, with the linear rails or linear drive motors, with turning as well, if you're on a small machine, you're going very quickly from point to point, aren't you? So the acceleration is everything. So the box guideway would make it slower, but the linear rails would make it faster. They might wear quicker, but you can replace linear rails. It's difficult and expensive to re-scrape the bed of a machine.
But the longevity should be there.
It should be there. So, have you got any more points? I think we covered. We nailed that one, didn't we?
I think it was absolutely brilliant. I think the last point really is when we mentioned twin spindle machines. Usually, you'll have the main spindle that is larger than the second spindle, and if you were looking to do the same kind of part on the main and the second, or you needed to bury it in the same way, you've got to, that can catch you out sometimes.
Yes, that's the difference between a sub spindle machine and a twin spindle.
Yeah, you've got to be careful. Sometimes if you want the same on the main and the second, and it can catch you out, so you've got to be careful, and you've got to replan your work accordingly, because you'd have to do one up on the main and then the second on the second, because you haven't got the same capability on the second as you have on the main, so you've got to be careful.
I've had that one where the customer said to me, I want a twin spindle machine, and I've got out a sub spindle, and he said, no, that's a sub spindle machine, I want a twin spindle. You're like, hang on a minute, twin spindle, sub spindle? Yeah, I want a true twin spindle machine, which essentially means what you can do on there, you can do on there. And that's, a sub is essentially a sub.
Yeah.
Isn't it? So there we have it. Our conclusion, just over 30 minutes there, Gio. Good podcast, that one.
Cheers,
we better go and get our football boots on and get ready for our next match. I'm not sure who we're playing, but hopefully we'll get to retain this nice trophy here. And hopefully you've enjoyed this podcast, and you can obviously check out all of our podcasts on our YouTube channel, and also on iTunes and all those various other platforms where we put it. Good stuff today,
Cheers,
Gio.
Paul.
See you on the next one. Mate. Thank you.